Welcome to nCast, the podcast from nOps. Each week, we'll explore the world of cloud cost management, the latest in AWS optimization, and getting practical about your FinOps journey. Join us as we dive deep into the latest trends, tools, and best practices, while having conversations with leaders and luminaries who are innovating on the front lines. Our goal is to provide value to the community through insights and practical advice that will help you to achieve your FinOps goals. So whether you're in engineering, leadership, finance, or a cloud professional, this is the place for you. Sit back, relax, and get ready to join the conversation on nCast.
Hi, everyone, and thanks for joining us for another episode of nCast. We've got an exciting guest here today, and it's taken us a while to be able to connect. So I'm really glad that today is the day. We've got Kristina Devochko, and I'm going to go through the list of just some of her many titles. She's a platform engineer, co-host of Kubernetes Unpacked podcast, and board chair of the Cloud Native Norway organization. The list really goes on from there. And I'm a big fan of the podcast. We're really happy to have you here, Kristina.
Hello, James, and thank you for inviting me. I'm happy to be here, especially thinking about the time it took for us to make this happen. I'm really happy that we actually made it happen.
So. Yeah, well, I think we both had some amazing travel schedules. You were at Kubecon Europe. Maybe you'd like to give us a bit of a rundown. What did you learn? What were the hot topics? What were your takeaways?
Yeah, I feel like I'm still recovering because as for all of you who have been at least once to KubeCon and Cloud Native Con, it's a very busy event, so like for 4 days, really 4 or 5 days tightly packed. So there has been a lot of things happening, and I still have a long list to watch through that I'm still working through because it's basically impossible to managed to see all the sessions. So it was a lot about connecting also with other community members. But what I could see throughout the event that was probably not surprising and kind of expected is a lot of sessions have been about AI and about how you could run large language models, for example, or on different AI services, intelligent workloads on Kubernetes-based platforms. So a lot of sessions have been related to that, and we could also see a lot of that in the keynotes. But apart from that, I also need to say, also based on that topic we're going to be discussing today, and also based on my community involvement being a tech lead of the CNCF Technical Advisory Group for Environmental Sustainability, we have also been closely watching the sessions and the content related to that topic as well. And I need to say that it was great to see one of the keynotes where a real life experience was shared by one of the German companies around what kind of environmental sustainability practices they have been implementing for their Kubernetes-based platforms to kind of try to measure their sustainability footprint of their workloads and kind of take actions upon that data. So we have also seen quite a few sessions related to that topic during the event, which I personally think is good and important.
Absolutely important. And I think year after year, we're going to be talking about sustainability more and more. It's obviously something that is critical, a must do, especially for the tech industry. And with the footprints that the data centers and their carbon impact, we all have to take responsibility. And you and I had a conversation a couple weeks, maybe a little over a month ago now, about the ways that optimizing for sustainability align with cost optimization, which is something that we discuss on this podcast quite a lot, and maybe sometimes the ways that they might not align. So it's sort of about organizational and hopefully your commitment to things that may not boil down to the bottom line. So I guess for you, how do you think sustainability and cost optimization align?
I think there is quite a strong connection between these two domains, but it is also important, maybe as part of this, to lift a very crucial distinction on that it is not always the case that by doing specific cost optimization actions, you would those actions would also in 100% of cases result in a more sustainable solution. That is not always the case, even though the correlation between cost optimization actions and sustainability actions is quite strong. So, for example, if you would be optimizing for cost, you would also be focused on utilizing only the resources you actually need, and the resources you're utilizing, you would be focused on utilizing them as efficiently as possible. And this action will also make kind of your solution more sustainable, because a big part of the discussions and the actions you can take around sustainability is basically avoiding unused orphaned resources, continuously cleaning up what you're not using, what is idle, utilizing resources you have to their max capacity instead of letting a lot of, for example, compute instances just being there utilized only 50% or maybe even lower, like some of the interesting reports have been showing, for example, from CastAI. I think their reports have been very interesting on that area, where they have been monitoring the utilization of resources on the Kubernetes clusters that have been connected to CastAI tools. And the 2 years now, they have been seeing that of almost half, almost 50% of compute capacity is not utilized on those clusters. So this is like a significant sign for us that by doing something about it, looking into ways we could use that capacity more efficiently, we could both optimize in terms of cost, because then we would not have need to pay for a lot of over-provisioned resources, and at the same time utilize them efficiently, and therefore having a more sustainable solution. But at the same time, I think it's important to mention that one of the myths we are hearing a lot is that cost is a direct proxy for sustainability. This has become a very popular expression, which is not necessarily always true. So it does not always mean that it is 100% correlation between these two, because, for example, if you would choose a region to provision your resources to that is powered by renewable energy sources, in many cases it will be more expensive due to that. Or, for example, going for reserved instances, for reserved compute instances, you may have a cost optimization there by getting quite a good discount. But if your demand on your workloads changes, if the load changes, if you make some optimizations to your workloads, then you can't if you reserve it for a few years into the future, you may not change that capacity to become lower, for example. So I think that it is important to also distinguish that there is a strong correlation between the two, but it's not 100%.
Yeah, that's an interesting topic of conversation. Clearly the public clouds will sell off unused reserved capacity on different markets, but it does play an impact in their capacity planning, right? You said you'd use it. I have to have those computers available and running. I'm interested if someone listening out there it is juggling these two concerns. First of all, how do you analyze the energy supply and the cleanliness and renewability of that energy supply when you're going through data center selection?
Yes, that's a very good question. Like the main challenge these days is that we are dependent when we are using public cloud providers. We are dependent on getting up-to-date, real-time data that would help us make better decisions. But it hasn't been easy, and it hasn't been as transparent for many cloud providers. So when choosing the region, you could use, for example, one of the tools that is called Cloud Carbon Footprint. That is an open source tool. Mm-hmm. I think it was initially started by Amazon at some point for a few years ago, but now it has been in the space for some time. Mm-hmm. And that is an open source tool. So it provides a visualization of the how much or how green the specific region is for different public cloud providers. And I think currently it supports 3 of the biggest public cloud providers, which are GCP, AWS, and Azure. But you have the possibility to kind of integrate some custom providers if you would like that, but it would require some work from you. So if you're using public cloud provider like the 3 mentioned, that could be quite an easy way to look into the overview. You don't even need to install the tool. You can get this map displayed for you so that you could see which regions are mostly powered by renewable energy sources and which are not. And for example, in Scandinavia, where I am based, most of the regions I think are quite green, so they're utilizing a lot of renewable energy sources. So this map can be of help for you to consider if this is one of the regions that you could provision your resources to, and still be compliant, of course. So this is one example. And then I think some public cloud providers at least are working on getting the data also available for you as part of their own solutions. So for example, Microsoft, I think, has been working with a sustainability API that should also help you kind of get that information available out of the box. But till now, I have mainly used the Cloud Carbon Footprint tool, which I think works quite well to get an overview of the regions to make such a decision. So, yeah.
I think that the direction that the cost optimization is going continues to align, I think, in terms of advanced type optimization, very much with sustainability. One of the conclusions that we have come to over at nOps is that overcommitment ultimately leads to less flexibility. And you start to think about, one of the tenets of cloud native architecture is portability, really being able to pick your workload up and run it anywhere in the world using cloud native tools. One of the first things that we see when we are doing analysis of customers who come to us with substantial workloads and targeted goals for optimization, I always ask myself, why did you pick this data center? Why, US East 1 in AWS is arguably the busiest data center in the world, which leads to a lot of outcomes. There's less available capacity, especially for popular instance types. So you're often driven to leverage more on-demand capacity. And so committing to high levels of price optimized strategies where I'm using pricing plans and pre-committing to usage really locks you in and kind of makes it harder to take advantage of many of the promises of the public cloud. The other thing that I found to be really interesting is that you mentioned some data that Cast has published. We have billions of dollars of cloud data flowing through our platform, and we've talked about it on this podcast many times. Sort of the journey that we went through when we were analyzing underutilized and idle computers, and the discovery when we started to associate these computers into auto scaling groups, that many of these computers were sitting around it in Kubernetes node groups, right? Which felt counterintuitive. A computer that may be consuming resources, but apparently is not doing any meaningful work. The CPU alone has no variation, which is the best leading indicator that something is idle. How can an organization start to measure their sustainability, and what are the top goals that they should be looking in terms of outcome? It can't just be, am I in a green data center? A big part of it is, how much resources am I consuming and why, and how can I attack that? What do you think?
Yeah, I mean, you are posing a very, very important and very good question there. There are quite a few steps that you could start to look into, and I think what you mentioned is also that many customers and many projects are making specific choices, maybe because they have seen others do that, or maybe because they see that it is being used in the documentation, and then that may not be a fully analyzed type of choice. Shall I use the same in my use case? So I think that is also what you have been observing, and you're the only one.
I'll give you a behavior hint. It's the default region when you first enter the AWS console, for instance. And so, hey, it's the console, or it's the region that loads by default when I log in. May as well start here, right?
Yeah, exactly. And I've seen quite a few cases where, pieces of infrastructure provisioning code has been just copy-pasted out of the documentation as is, with the values that have been used there, right? So there we see a concrete example of not a very conscious choice that is suited to the use case you are in, right? And there are quite a few factors that should be taken into consideration here. And both for cost optimization, but also for utilizing the resources you have more efficiently. So circling back to your question on how can we kind of approach this topic of optimizing for sustainability. Apart from the region, there are quite a few areas that we could look into. And first of all, you would need to start by measuring how the power consumption is, how is the CPU and memory usage of the workloads that are running on those nodes in a Kubernetes cluster. And there are tools that can help you with that. Many cost optimization tools these days actually provide you this information regarding utilization of the nodes depending on workloads and how the load to those applications is changing throughout the day, and they can come with recommendations in terms of, for example, choosing a family type for those nodes. How much CPU and memory applications running on those nodes actually need? it's not always given that you need to scale out a lot or you have hundreds of applications. Maybe you have quite a few that don't need those so many nodes running there, but you have just made a specific choice just to test it out and see. But if it's just a black box, if you're not monitoring that information, if you're not seeing how the resource utilization is changing throughout the days, you can't make an informed decision on adjusting that. So some cost optimization tools out there are available for you that could provide this information, and some of them even have automation in place, so it could actually do, for example, if you allow it to do, it can start kind of changing and scaling in or scaling out, for example, like KEDA for event-driven scaling. You could utilize that to really drill down to not just utilize CPU and memory as metrics or scalars to make decisions when you need to scale out or scale in, but actually use some even more custom metrics that make more sense for your application, like, I don't know, HTTP requests, for example. So another opportunity is Karpenter, like that is also a very interesting way. There are some, we can mention it maybe later, but there are some interesting ongoing discussions there around how Karpenter as a cluster autoscaler, for those who haven't used this tool before, it's a cluster autoscaler that is very efficient in terms of like provisioning new nodes in case of demand scaling out, or in case of increased demand, and also it can consolidate your workloads and therefore reduce nodes as well when you have less demand, for example, happening to your workloads. And there are some discussions on like, can we take Karpenter functionality further and also take data about, take emissions data at this point in time for every day and take this data into consideration when we're doing the scaling, so that, for example, the workloads that are not critical, are not time critical, for example, and can be run at any time, will then be executed when the energy, you can say, is greener. So when there is less demand and when the energy is coming from renewable data sources, for example. So these are some of the tools that you have available to kind of look into how you could scale more efficiently and how you could adjust the amount of resources you're using for your workloads. And lastly, one more thing I will mention to not talk too long at one time is for measuring, for example, power consumption. An interesting tool that is currently a sandbox project in CNCF is called Kepler, and that is a Prometheus exporter. So Kepler you could use Kepler to kind of gather metrics about power consumption of your pods and nodes, and then you could visualize that in a Grafana dashboard, for example, and even connect some machine learning aspects into it to kind of provide you some recommendations in terms of like adjustment.
Sure. Well, I have so many comments and thoughts about what you said there. One thing is, and a lot of the reason that I'm very proud of some of the work that we're doing over here at nOps, we have a value that when we deliver an optimization feature, we really want to provide engineers all the data that they need to take action confidently. What we've learned in this journey is that many tools provide millions and millions of dollars worth of recommendations that are never acted upon because there's not sufficient data to give engineers the confidence to actually take action. And so we've really focused on integrating with existing monitoring tools, right? So now we can ingest data from Datadog or your CloudWatch enhanced agent and start to introduce more data points that allow us to help engineers to take action. But one thing that came to mind is in terms of simple steps, we often have conversations with clients onboarding to the platform, and one of the simplest actions that you can take, and we have automation for this that makes it ultra easy, is just to schedule resources. What a huge impact you can make is spin your clusters down in QA lab and UAT lab. It has the biggest impact on cost, and it's one of the foundational principles of using the public cloud. Don't use resources when you don't need them. You can save $2 for every $1 in hourly resource cost by scheduling or pausing an idle resource, because there's a network impact. That you're paying network costs, there's loads on databases, so that computer is generating more costs, and obviously it's costing money in terms of efficiency and energy. I'm very excited about your thoughts around integrating carbon efficiency, the APIs and metrics into auto scaling. You talked KEDA, so pod level auto scaling, and then we talked Karpenter. I'm here to tell you that based on the work that we've done with Karpenter, we're very active in the Karpenter community. It absolutely can be done, right? And so, the problem is that I think most DevOps engineers, just based on time, don't have time to go back and review configurations. And that's why automation is key. Continually updating Karpenter configurations, for instance, allows us to prefer, instance families that are more available, that are more cost optimal. But I think that we talk about portability in terms of data centers. Sure, I can run my workload on a Kubernetes cluster that's in data center 1 versus data center 2. But another real key to unchaining, I believe, is diversity in the instances instance families that you allow to run in your workloads. What we see is that most organizations heavily invest in very popular instance types, like C5s are great. C5As at face value have a great price performance outcome, but are not considering maybe 20 other instance families that could be suitable for that same workload. And that they may have similar architecture, they may have similar memory, they may have similar clock speed, but we know that C5A works. And so one of the things that I wanted to get into is the concept of leveraging available capacity, right? So we know that all the public cloud providers sell off available capacity. It's good for the cloud providers. It's good to you. You get a price discount. One of the most important things that you can do to successfully take advantage of that capacity is broaden the diversity of instances that you can leverage, that you can run as Kubernetes worker nodes. How does leveraging Spot or any available capacity option play into the overall picture of sustainability?
Yeah, I totally agree with you. I think that is also a great question that also boils down to a few things, both like, okay, this is my comfort zone. I know that this works and that is stable, and I don't have time or capacity to explore or make my workloads ready to be running in a stable manner on different types of compute families, for example. So that is one important point. And the other one that I think I've recently read in one or the other article, that a very typical like mindset that administrators have is that we need to have servers that are over provisioned to ensure that if load changes or load increases, we always have this additional capacity in place when it's needed. But when you start actually measuring that, in many cases, that capacity is almost never used. And that's why you choose maybe the size of the compute sizes that are over provisioned, just to have that safety feeling of that it is always there in case you need that. And spot instances is a good example of how you could help utilize capacities that is currently not in use by the public cloud providers, and therefore you contribute to utilizing as many resources that are currently free as possible, which is a good thing, because then you utilize resources more efficiently. But I think that what the challenge is here is the applications architecture, and if those applications can kind of be run successfully in spot instances. And one thing is dev and test, but then what about running spot instances in production? Is it possible? Because currently many actually fear that, when there are good examples of from quite a few companies that are running spot instances in production, all clusters on spot instances. That was super cool.
We're running 100% of our production environment spot eligible.
You do? Awesome.
Well, I mean,
right there. We need to talk about that. We need to talk more about that.
We have to drink our own champagne. We're even running databases on spot. It can be done. With a little bit of effort and really accepting the tooling out there, right?
That's amazing.
You have to embrace tooling.
That is really, really great, and we need more visibility around those stories, because I think there is quite a lot of fear there. But of course, it would require some effort potentially to make your applications actually ready for that, to be able to handle these intermittent failures, or like when the node is being taken back from you. So your application, of course, would need to handle that, but the pods at any point may disappear as well. So you kind of should think about this already when you are migrating to like containers and Kubernetes. So this is the part of the deal, you could say. So yeah. I think that also when it comes to sustainability, when it comes to cost optimization, a lot also comes down to the application architecture. That's why, for example, lift and shift is often can be a fast way to start running on cloud, but it can be quite costly, and it can consume loads of resources when you could actually optimize the architecture to make it more cloud native, for example.
Well, at that point, you have to ask yourself, why am I making the decision to move to the cloud? We work with a lot of entry point into using our optimization features. Starts with a map migration. We have a map migration tool. We make it easy to track your migration into AWS, for instance. Outcomes, however, are almost always unexpected or not meeting expectations if you're not looking at modernizing your application. But one thing that I can say is that the number one inhibitor to spot adoption is fear. And so that, I have come to the conclusion that when we talk about our spot automation capabilities, I can tell you about analyzing the spot market, and I can tell you about configurations that you can make to make sure that things handle gracefully, or that the agent that we put onto your Kubernetes cluster makes things happen more smoothly. But at the end of the day, I don't want to talk about Spot like it's magic. And so when I talk to even our engineering team, I always say that our number one goal is to make it easy to do Spot correctly. And actually, if you take some simple principles in mind, I'm not invested in one instance family or one instance family and size, means that I'm less likely to get a mass termination event, right? Because those things happen in waves when people decide to claim their reservations, for instance. AZ plays a big role, and if you don't have to think about that stuff, some AZs at any given point of the day or month are going to have better Spot outcomes than others. Pod disruption budgets. You go down the list of things that you can do, and I think that there are a much larger percentage of workloads out there than people really think that are suitable for Spot. And we help customers to discover that every day. And it's really much more about making it easy to do it efficiently, and hopefully taking away some of the daunting decisions. I really hope that there's a future where we boil workloads down to requirements and not instance families. All I want to know is, this is what I encourage people to do: stop thinking about the 750 AWS instance families or options that are out there on the market today, and start thinking about, what's my network requirement? What's my CPU architecture? What are my memory and core requirements? What clock speed? Do I have any special networking features? Because if you can dissolve your workload down to that, then what you can do is open the door to making more intelligent decisions, and demystify the idea that some engineer a couple of years ago decided that an R5 was the best thing, or determined that my workload runs on that. It sort of locks you in and prevents you, I believe, from making both sustainable and cost efficient decisions.
Yeah, absolutely. And also looking at it from the perspective that it's not a one-time choice. It's not like a static choice, that
Right.
Your application is not static in 99 out of 100 cases. I don't know, probably in 100 out of 100 cases, unless it's legacy maintenance. But I mean, your applications are constantly developed, and their needs will also change. So at some point you may make it efficient, which would mean that it would use much less CPU and memory, for example. And then maybe that would make sense to adjust and use a smaller type of instance, right? So this is also a journey that will be continuous, and you would need to continuously look at your application and how its needs change over time as well.
Sure. And think the same way with container sizing. Your data size changes over time. Efficiencies are introduced into your workload. I encourage people to open your mind about turning some of this responsibility over to automated tools, because if you prescribe that in infrastructure as code only, it's generally not going to get revisited for a long time. But also your workload patterns change over time, and if you find a tool that gives you the confidence that it's going to be based on data to intelligently adjust your container sizing based on the trends that are in actuality of your workloads, that the outcomes can be much better. I think there's more work to do there, but I like to think that there's a category of tools that are really getting there today. And even starting out with something like VPA, just running it in dry run mode to get some idea. But I like to think that the NOps is in that category. But there are a growing number of tools out there that really can help you to do this. So I guess, we're a short amount of time left for us here. That brings us to tooling. We've already kind of talked about a couple of things. Everybody out there knows we're big fans of Karpenter over here. You talked a little bit about using KEDA and maybe making KEDA more carbon aware. What do you think are the most interesting tool decisions out there that organizations can look at?
Yeah, I think that at least I could recommend to look into Kepler, because that could help you to get information about how much power, for example, your workloads and nodes are consuming. So you could also integrate this information into existing Grafana dashboards. So that could help you to get some interesting data visualized for you. So that can be an interesting tool to start with. And this is something we are working with right now in the Environmental Sustainability Technical Advisory Group, because we have a separate working group right now that is called Green Reviews, where we are focusing on measuring the resource utilization and power consumption of CNCF projects like Kubernetes, for example. Right now we have Falco as our first project that we are evaluating, and our goal is to build a platform or a workflow that could be used to kind of measure the footprint of the CNCF projects in the whole landscape long term, and make this information available so that community could also see how the sustainability footprint is changing for the CNCF projects over time, for example, so that informed choices can be made and projects can be improved. And we believe that long term this workflow can be serving as an inspiration for others. And for that, we are utilizing Kepler to start measuring that power consumption when the tool is under load and is running in the clusters. So this can be also an interesting place to learn more about it if you are curious. Apart from that, KEDA is definitely, like I mentioned, a tool that can help you scale even smarter. And right now there is like an experimental carbon aware KEDA operator that has shown some successful results to be used in test and dev. So you could use that operator to integrate that with third-party APIs like what time or electricity maps to get emissions data for the different regions and for different electricity grids. And then, for example, in dev and test, say, okay, when this during the day, if the energy is very carbon intensive, so like dirty, comes from non-renewable energy sources, I don't want these workloads to scale more than to so many replicas.
Right.
But it's okay to scale to more replicas when the demand goes down and the region becomes less carbon intensive. So for example, for dev test, if you're already using spot instances and you don't have critical workloads, you could already start playing around with that and integrating that and see how that works. So
yeah, sounds like a great option for certain types of batch workloads as well, that may have a time horizon of, hey, we need to get it done today. Doesn't matter whether it's at 11 p.m. or 3 a.m. It just needs to happen today.
Yeah.
Well, I feel like this conversation could go on and on.
Yeah.
I know maybe we have more opportunities to do this again. If for instance, I'm absolutely convinced that we can integrate Karpenter with the tools like WattTime in the same way that you mentioned that this carbon aware KEDA project is doing. I think there's so many exciting things that are yet to come, and it just takes a mindset of opportunity and being able to solve tough engineering problems.
If I may, like once you mentioned that very quickly, I just want to also let you know and the community know, maybe someone feels also the calling. One of our environmental sustainability tag members wrote a master thesis proposing how Karpenter can take carbon emissions data from third party like Boa Vista API, which is an open source API that contains this emissions data, and take it into consideration also when performing the scaling decisions. And there is an issue in the Karpenter project on that discussion, and if you would like, with the proposed solution there as well, and how to change that in the upstream Karpenter project. So if you are interested to support that, I hope that we can make this link happen available.
Well, ask this person if they're interested in a job over here at nCast. I'm putting that one out here right now.
You could look at the author of that issue.
Right. Maybe I'll have our head recruiter track down their LinkedIn. But I'm putting it out here on this episode. Whoever the author of that paper is, call me, email me. I'm at james@nops.io. But yeah, I will go find that issue. I hadn't seen it, but it makes so much sense.
So if you would like to support that, I think it really needs some support from the community so that it can be convincing, like to prioritize or like invest time in that. And it's always nice to get support for impactful changes like that, so that you don't feel lonely in what you're trying to make a change for. So if you feel like it,
that pushes the limits of what we can do. And hey, if Karpenter doesn't have the data or it needs back-end integration, maybe you can help talk our product manager into just adding it as a value-added feature into Karpenter. We could do that.
Wow. Now we're talking.
Yeah, there we go. So Kristina, tell people where could they find you? I'm sure they're going to be interested if they haven't run across you to learn more.
Yeah, so I am easy to be found with my name, Kristina Devochko, on LinkedIn or Twitter, X these days, and I also try to blog a bit on my tech blog, christhecodingunicorn.com. And also, if you are more interested in the topic of environmental sustainability in cloud native, then do join our technical advisory group. It's open for all, so you could find what interests you most. For example, we're right now working on a document for best practices for in terms of making Kubernetes clusters more sustainable. So it is coming, and it's open for folks to share their experiences as well. So if you would like to join or would like to talk to me about that, also reach out to me, either on LinkedIn, X, or in the Tag Environmental Sustainability channel in the CNCF workspace in Slack.
Great. I think if people just Google you, they'll find the many content contributions that you make in general to the community.
Not to brag, but
not to humble brag, but hey, it's not bragging if I'm just speaking the truth, right?
That's nice.
Well, this has been a great conversation, and like I said, I really hope that we can have more of these conversations in the future. If there's anybody still out there listening and you found this to be interesting, you're probably just as nerdy as Kristina and I are and passionate about these things. So join us for the next episode of nCast, because we've got more interesting conversations coming. And again, thank you so much, Kristina. It's been a great conversation.
Thank you for having me. Thank you, James.
All right.
Thanks for tuning in to nCast. We hope you enjoyed the episode. As you can tell, we love to geek out on all things cloud optimization. If you have any questions or feedback, we'd love to hear from you. You can find us on LinkedIn, Twitter, or Instagram, or just shoot us an email at ncast@nops.io. If you'd like to learn more about the continuing innovation over at nOps, or about our free FinOps platform where you never pay anything unless you save money, check us out over at www.nops.io. Until next time.